Okay, so today we're doing graphing logarithms. So, like I told you guys in class, each of these, I would like for you to start with the parent function and then do the translation afterwards. So, number one, let me zoom in just a bit. Oh, that's about as big as it gets. Okay, never mind. Number one, so you will always have a first point at 1, 0. The second one is, and since this is a log base 2, you will be doing 2, 1 as your second point, right? And then from here, so this is your parent function, and if you were to graph this function, it would look something like this. Okay, except we're not graphing it, so it would look like this. Okay, but we're not graphing it, so undo, 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 and then we're just going to do a transformation based off of these 2 points. And this right here, the positive 5, is inside with the x. So therefore, it's going to be a translation of -5 to the left. So each of these blue dots, I'm going to go 5 to the left. So 1, 2, 3, 4, 5. And this one's going to be 1, 2, 3, 4, 5. And this is the one that you are going to have to graph. So you're going to go ahead and start and do that. And then remember, from here on out, you're going to go about one block back, and you're going to go. See, I already messed up. All right, so you're going to go and just go straight down from there. Okay, and that right there is our log base 2 of x plus 5. Okay, and leave those two blue points, or whatever color yours is. All right, so I'm going to speed it up just a little bit, because if you forgot, this is going to be how we're going to do it. So number 2, first point right here at 1, 0. Second point, since this is a log base 5, we're going to go 5 and then up 1, and that's going to be your reference points, or the points for your parent function. Then you have to look at what the transformation is doing in this function. This is a -2 inside with the x, so we're going to go ahead and do the opposite of that. So it's going to be move each of them 2 times to the right, just like how I'm doing there. And then this is a -4 on the outside of the log function, which means that it's going to be a translation of a -4 in the vertical direction. So each one of these are going to be down 4. So down 1, down 2, down 3, down 4. And same thing, down 1, down 2, down 3, down 4. And that's going to be your resulting transformation. And if you like, you can remove those arrows or erase them like how I'm doing it. Then go ahead and graph your log function. And again, connect these two, and then you're only allowed to go about maximum 1 block to the left. And that's about all you got for that part. And then just extend it out a little bit and draw your arrow, and that is your function of log base 5 of x minus 2 and then -4. All right, moving on to number 3. Same scenario. We're going to go ahead and put our first reference point, which is at 1, 0, and then this is a log base 3. So we're going to go to 3, and then we're going to go up 1, and that's going to be our 2 reference points. And inside the x in the function, that's going to be a +4. So we're actually going to translate this 4 times to the left. 1, 2, 3, 4. 1, 2, 3, 4. And then this is a -5 on the outside of the function. So we're going to go down 5 for each of these. So it's going to be down 1, down 2, down 3, down 4, down 5, and same with the other point. Down 1, 2, 3, 4, 5. And that's where you're going to end up with your translated points. And again, we can get rid of this just so that it'll be a little cleaner, and then go ahead and connect your dots and kind of make it slightly curvy so it looks like a logarithmic function. Then again, over here, it's going to just curve down 1 block over to the right, to the left, excuse me, maximum. Okay, number 4, you notice this is a log base e. So our first reference point is going to be at 1, 0. And the second one's going to be at e. And remember, e is approximately 2.71. Right? So you're going to go to 2.71, which is between 2 and 3, closer to 3, and then you're going to go up 1. You're going to end up right here. Okay, those are your 2 reference points. And you're going to go ahead and translate those depending on what the transformation tells you to do. So if you look here, it says plus 1 inside of the x, so that means we're going to go to the opposite. We're going to go to the left 1 time. Okay, and then on the outside of the log argument, that is a minus 1, which means that you're going to be going down 1. Because remember, outside is the same, inside is the opposite. So inside with the x, you're going to be doing opposite. Outside of the x, it's going to be the same. All right, so that's your transform point, and it's going to be right here, which is at 0, -1, and then right here, which is in between 1 and 2, and it's on 0. So that's going to be a what's that? 1.71, and then comma 0 for that one. So these points after the transformation are very close together. So it's going to look something like that. Then here it's going to go again maximum 1 unit over to the left only. So it's going to go straight down from there. That is, your transform point. Okay. 5 and 6. Identify the domain and range and then sketch the graph. Okay, it's probably easier to sketch the graph first and then identify the domain and range. Right? So this next one right here, I'm going to go ahead and do our reference point. 1, 0, and then this is a log base 3, so we're going to go to 3 and then up 1. That's our reference point, and then we're going to go ahead and use the transformation that it's telling us to do, which is a translation of right 1 for each of these points, and then down 3. So down 1, down 2, down 3, down 1, down 2, down 3, and these are going to be your 2 new, or the 2 corresponding points for your transformation. Oops, let me see. I need to break that apart. I need to ungroup that. Okay, so there you go. And there you go. Oh, I have a little piece left over. Too many pieces. Oops. Okay, this is just not looking good. But I think it was, let's see, down 3. So right 1, down 3. So right 1, 1, 2, 3. Then right 1, 1, 2, 3. Okay, perfect spot. Okay, and then you're going to go ahead and connect your points and make it look like a logarithmic graph. And then again, to the left of the first point, you're going to go maximum of 1 unit over, and you're going to go straight down from there. Okay, so that's our graph, and then I think it's easier if we graph it, because now we can see that our domain is going to be, and if you think about this, right, domain, you can go as far as this, not that line, excuse me, you can go as far as, actually, yeah, I was right, this line only, right? So, and then it's going to be able to, you're going to be able to go out to the right as far as you can see. So it's going to be starting at 1, and it's going to go all the way to infinity, right? That direction. Okay. So our domain is going to be, and it doesn't actually reach 1, even though we're allowed to go a maximum of 1 unit over. That's the maximum, and we won't even go 1 unit over. It'll be a little bit less than that. So it's going to be parentheses 1 to infinity, and both of them have parentheses on it. The range, okay, range is going to be how far down to how far up. And if you look at the arrows on this graph, it's going to go very far down, all the way down, in fact, to negative infinity. And how far up? It's going to slowly rise up, but eventually it's going to keep going up and up and up. So it's going to be to infinity. Okay. Okay, number 6. Again, our reference point, our starting point for our parent function is at 1, 0. And this is log base 3. So we're going to go to 3 in the up 1. And these are our two functions, or 2 points that we'll be using for the transformation. All right, from here, all we see is a plus 4 inside with the x, which means that we're going to go to our right. Excuse me. That's a plus 4, so we're going to go to our left 4 times. So 1, 2, 3, 4. And 1, 2, 3, 4. And that's about it. All right, so we're going to end up with a point right there and a point right there. And to clean it up a little bit, I'm going to go ahead and remove these arrows. And then I'm just going to go ahead and draw my logarithmic function, go through those 2 points. And then again to the left of that, no more than 1 unit away. So it's going to look like that. And it's always going to go down. Okay, so in this case, I'm going to use green for this. The domain is going to be, and you can see that you're going to go as far to the left as this line only. You won't ever pass that line, which is at -4. Right, so at -4, that's the maximum you can reach, and you actually can't even reach it. So the domain is going to be from -4, and then it's going to keep going to the right. So that's all the way to infinity. Okay, the range, you see it's going to go all the way down to -infinity, and then it's going to slowly go up, which means that it's going to go to positive infinity. All right, so that is your number 5 and 6. Okay, next page. So this page, I was hoping if you do need help on this page, go ahead and look through the video and fast forward through it. But I was hoping that after you graph each of them, you will see something special. But I'll graph it first, and then we'll see. And I won't say anything until I've graphed all of them. Okay, and I'll leave all of them on here. So first one is 3 to the x power. That's f of x. I'll put that in the red. So remember when we did this, and I'll do this for the first one. When we were graphing exponential, we graphed it as we made an xy table. We used -1, 0, and 1, and then we plug this -1, 0, and 1 into this x right here. So we plug 0 in, starting with the easiest. 3 to the 0 power is going to give you 1. You plug 1 in, 3 to the first power is 3. You plug -1 in, 3 to the -1 is going to be 1/3. So when we graph this, we'll end up with 0, 1, 1, 3, and -1, 1/3. So it would look something like this. Okay. You can pause anytime. I'm going to go ahead and erase this. Okay. I'll leave that there. The second function is what we're working on this week, which is logarithmic graphing. And then what we talked about today is we have a reference point right here. And then this is a log base 3. So we're going to go 3 in the up 1. And we're going to go ahead and graph that. And again, you only allowed maximum 1 unit over to the right, to the left, excuse me. Okay, so you may see something, but you might not, and it's okay. I'll say something at the end. But if you do see something, that's why I want you to actually notice. Okay, next one. We'll go with exponential is going to be in red. So that's 9 to the x power. So again, you can go ahead and do a table. Here, I'll do one more time. So x, y table. I'm going to use -1, 0, and 1. And if I put 0 in, start the easiest one. So if I put 0 into the x, it'll be 9 to the 0 power, which is going to be 1. If I put 1 into the x, it'd be 9 to the first power, which would be 9. And then 9, and then put -1 in, you get 1/9. All right, so that's our table of values for the exponential function, and it looks something like this if you graph it. Right there, 0, 1, 1/9 right here, and -1, 1/9, which is almost on the x-axis. And if we were to graph that, it would look something like this. Okay, so that's our graph of the exponential function 9 to the x power. I'm going to go ahead and graph the logarithmic function of log base 9 of x. And again, it's going to start all log functions, like how we talked about it today. Starts at 1, 0, and then this is a log base 9, so we're going to go to 9 and then up 1, and then we're just going to go ahead and connect those. And 1 unit maximum to the left. Okay, and again, hopefully you see something that's similar about these two. But moving on. Okay, so going forward, I won't be writing the table value for the for the exponential function anymore. All right, so we've got first one, which is f of x, 4 to the x plus 2. All right, so when I do this, I'm going to go ahead and graph the exponential parent function first. So this one's going to be 0, 1, 1, 4, and then negative 1, 1, 4. And then I'm going to go ahead and move each of these 2 units to the left. So that's right here, and right here. And I'm going to go ahead and graph that. And I'm going to put in a smaller line. But that way it looks a little nicer. Okay, that's going to be okay. I'm going to go ahead and do the logarithmic function, and I'm going to go ahead and start with the graph of the parent function, which is the log base 4 of x, which is there. And then since this is base 4, we're going to go to 4 and the up 1. Okay, and then this one has a transformation of a minus 2 all the way at the back, which means that we're going to drop each of these down 2 units. So 1, 2, and 1, 2. And I'm going to go ahead. And again, I'm going to do this in tinier, sharper line. So it's going to look something like this. Like that. Okay. Hopefully you're seeing something, but if you don't see something, it's okay. Last one. Well, last one for this next section here. So the parent function for this function is a 2 to the x power. So I'm going to go ahead and graph that. So at 0, it's going to be 1. At 1, it's going to be 2. And at negative 1, it's going to be a half. Okay, except this time around, it has a transformation of plus 4 in the back. So I'm going to go ahead and translate this up 4 times. So 1, 2, 3, 4. 1, 2, 3, 4. And 1. So we're at the 1 half. So the next 1 half. So 1, 2, 3, 4 at the fourth 1 half. Again, I'm just going to go ahead and graph this in. It's going to look something like this. Okay, I'm going to leave those 3 red points there. Okay, second function is the logarithmic function of log base 2 of x as the parent function. So I'm going to go ahead and graph that. So it's going to be at 1, 0 as the kind of like the starting point. And then we're going to have a log base 2. So it's going to be at 2, 1. And then I'm going to go ahead, and this one actually has a minus 4 on the inside with the x, which means that we're going to do a translation of positive 4 to the right. So 1, 2, 3, 4. And right here, so 1, 2, 3, 4. And we're going to go ahead and graph that in. Again, maximum 1 unit to the right, and then it's going to go straight down from there. Okay, so hopefully you see something, but again, if you don't, it's okay. Okay, so actually, I was anticipating something, but just to sketch the graph of each exponential function f of x and logarithmic function g of x by hand. Right, so okay, now the bottom two are the two that I kind of want you to see. Okay, and you might have noticed. Well, let's talk about it now, right? So for all of these, what did you notice? Right, so you might have noticed that for each of those functions, it looks like it looks exactly the same along the diagonal, right? Let's see, right there. So it looks like it's a mirror image of each other right along the diagonal. And I hope you remember what that's called. Okay, and if you don't, keep working. Right, so for each of these, totally looks like mirror image or a reflection right across this middle line of y equals x. Okay, so if I was to fold that along that middle diagonal green line, they would look exactly the same, or they would fall on top of each other. Okay, last two then. All right, so first it says find the inverse of f of x and graph both functions. What do you notice? So you might already, I might have alluded you to what's going to happen, but let's go ahead and find the graph of f of x. So f of x, and again, remember to find the inverse, you're going to switch f of x for y. Actually, I'll work it down here. Much more space. And then I'll write the answer back up there. So f of x, I'm going to call that y. That'd be 10 to the x power plus 1 power, and then minus 5. We're going to go ahead and swap your x and y. Remember, if with inverses, that's the second thing you do is swap x and y. So the x equals 10 to the y power plus 1 minus 5. Okay, now you're going to have to solve for y. So this may take a little bit of work, but I'm going to go ahead and I'm not going to write all the steps down because you guys are big boys and girls now. So I'm going to go ahead and just add 5 to both sides. So add 5 to both sides gets rid of that minus 5. So on the left-hand side, I'll get x plus 5 equals 10 to the y plus 1 power. Right now, you may not remember how to do this, but to get rid of a base 10, and we'll actually learn about that, but you may have learned it previously, to get rid of a exponential base 10, you can do a logarithmic base 10 both sides. Okay, and if you do that, you will get log base 10 of x plus 5, and that x plus 5 is in parentheses because it's log base 10 of the whole thing, and then it's log base 10 of 10 to the y plus 1. Okay, and one of the properties we just learned last week was that a log base a of a, that's going to allow you to cancel out and just keep your exponent. So if we have a log base 10 of 10 to the y plus 1, that's all going to cancel out, and it's going to leave you with just y plus 1. And on the left-hand side, you can't do anything there, so we will just have a log base 10 of x plus 5. And that's all you can do. Right, now to solve for y, we're just going to subtract 1 from both sides, and we will get y, which remember is actually the inverse. So y inverse is equal to log base 10 of x plus 5. And then to get rid of that plus 1, we're going to have to subtract 1. So you can put it in the back, which looks a little cluttery, or you can put it in the front as a minus 1 plus. So it's up to you how you want to do this. Right? So you can leave it like this, and there's nothing wrong with that. It's just a little, cluttery, like too much stuff on one side. But you can also write as negative 1 plus log base 10 of x plus 5. And that's going to be your y inverse. Okay, so either one's fine. Right? So you can have this one, or you can have this one, and it doesn't matter with either one. Okay. Okay, actually, I'm going to go with the top one because that's the first one I wrote. Okay, and I have the parentheses in, so it won't be as confusing. And that right there, that's going to be my inverse, and direction says graph the function and its inverse. So I put down y inverse, but it's actually the inverse of f because that's what we started with. So I'm going to go ahead and write down, I'm going to put in red, f inverse of x equals log base 10 of x plus 5, and then minus 1. That's my inverse. Okay. And to graph that, so I'm going to go ahead and graph my original in blue. So my graph of f of x is in blue. Okay, and that's exponential function. And then I'm going to go ahead and start with the graph of the parent exponential, which is 0, 1, 1, 10, and negative 1, 1/10. And again, you can use a table of values to find those points. Okay, and this has two transformation. It's going to be to the left. Oops. It's going to be to the left one time because that one is with the x. So left one time, and then it's going to be down 5. So I'm going to do both of those at the same time. And no arrows because it's going to get a little too crowded. So left once and then down 5. So I'm going to go left once. I'm going to start with the 0, 1. So left once and then down 5. So 1, 2, 3, 4, 5. And that's my new center. Okay. So for this top one, it's going to be left once and then down 5. 1, 2, 3, 4, 5. And this one here, it's at the 1/10. So it's going to be left once and then down 5. 1, 2, 3, 4, 5. And it's down here. Okay. So you might actually not remember which ones are which. But we have this one, and this one. So I'm going to go ahead and graph my function through that. So it's going to be, let's see. So it's going to look something like it's going to be over here, up here. And come down, hit that. Redo. Hit that. Redo one more time. And then let me start at the bottom right there. Go up and hit that. It's going to continue going up. From here, it's just going to even level out right there. That's my blue one. Okay. My red one, this one here. I'm going to go ahead and start my parent function. This is a log base 10. So all logs start at 1, 0. And then this is base 10. So 10, 1. Okay. And I'm going to go ahead and do transformation from there. Transformation is, for this one, left 5. And then down 1. Okay. So left 5, down 1. Okay. So for this one, left 5, 1, 2, 3, 4, 5, and down 1. That's one I want. And left 5, 1, 2, 3, 4, 5, and down 1. Okay, and again, there's a bunch of points, so it may be easily lost, but we want that one and that one. Both of those have been moved to the left 5 and down 1. So if I graph those, it's going to look something like, oops, too much. Like that. Then maximum 1 unit over, and it's going to go straight down from there. That actually looks pretty good. All right, so you're supposed to graph that, and then what do you notice? Again, I already alluded to this earlier, but you should notice that, again, this diagonal line hits it, and it actually cuts it. You can see that it actually cuts each of them at the center, and you can see that these two cross it right here, and it cuts it both in half right here as well. So, okay. Same thing for the last one. Okay, last one is a natural log. So first we're gonna go ahead and do the inverse. So f of x, we're gonna call that y, like that. So it'd be y equals 3 plus ln of x. Right? Leave that back to f of x. Swap x and y. So that would be x equals 3 plus ln of x. Right? And then we're gonna go ahead and try to solve for the, whoa, what happened to my y? Oh, sorry, I didn't change that to a y. So it'll be ln of y because I swapped the x and the y. All right, so solve for the y, meaning get rid of the 3. So minus 3. So I'll have x minus 3 equals ln of y. Ooh, I wonder how that sounds on the other end. Excuse me. Okay, now to get rid of the ln, okay, remember ln is the same as the log base e. So if I want to get rid of a base e, I have to do a e both sides, a big E. Big E. You know, biggie big. All right. So I will have E to the x minus 3 equals e, remember big E, to the ln of y. And remember, ln is really log base e. So one of our properties says that if we have a, actually, let me rewrite it as a log base e of y. Okay, and remember, one of our properties says that if we have a to the power of log base a, then that we will only then that's going to cancel out, and we'll be left with just a y or whatever that's at the argument location. Okay, but in this case we have e to the log base e. Okay, remember log base e is really ln. So an e as a base to a log base e will also cancel out. Okay, and we will be left with just the y. Yes, just the y, because these e and ln, which is log base e, those will cancel out in a sense. Okay, on the left hand side we have e to the x minus 3, and we actually have solved for this. And remember, once we solve for it, that's actually the y, or in this case this is our f inverse. So we'll say, oops, I don't know what happened there. So we'll call this f inverse of x equals e to the x minus 3 power. Okay, and again we'll start with this case we'll start with our logarithmic function. Okay, this is ln of x, and remember ln is really base e. So first point is at 1 0, like every other log function out there in the world. Okay, second point is going to be 3.71 and then positive. Sorry, 2.71. I don't know what I was thinking. 2.71 and then positive 1 or up 1. Okay. Okay, now this ln of x also has a translation of positive 3. So I'm going to move each of these up. Actually, I'm going to do this. I'm going to go ahead and, no, you know what? We'll leave it on. I'm going to move it up 3 times. So 1, 2, 3. And we're going to end up right there. So at 2.71, we're going to be 1, 2, 3. And it's going to be right here as well. And again, we want these 2 points right here. Okay, and if you don't want to do, well, I did just erase the original 2, and then you won't get so confused. And we're going to go ahead and graph that. And remember, to graph it, you're going to connect these 2 and just kind of slowly grow it out. But to the left of it, you're only going to go down go to the left maximum of 1 unit. And that's going to go all the way down. Okay, that's our 3 plus ln of x. Second function. Okay, so I'm going to go ahead and graph my exponential function of e to the x first, and then I'll put that in the minus 3. So e to the 0 is 1. E to the 1 is 1, and then 2.7. So that's about right here. Wow, pretty close to that. And then over here, it's going to be down here. Okay, I don't know exactly what that number is, but I know it's down there. Okay, and then I'm going to go ahead and this one has a little minus 3, which means that I'm going to go and move to the to the right 3 times. So each of these, 1, 2, 3. Wow, this one ends up right there. This one, 1, 2, 3, about right there. And this one, 1, 2, 3, about right there. And again, if you don't know which one we want these 3 right here. Okay, and I'm going to go ahead and just graph my exponentials. So just connect those. And then remember, exponentials just right along the x-axis. Okay, and then what do you notice? Well, hopefully you notice again that if we go from diagonal to diagonal, we can actually see a mirror reflection, right? And that's how you know something is an inverse, is if it's a mirror image of each other along this line. And remember what the line's called? This diagonal green line for each of these. There's all going to be y equals x. These are all the line y equals x. Even this little itty bitty one, y equals x. Okay, and this one. All of them. Okay. Okay, we'll stop there. I think that was a long enough video. See you guys tomorrow.